Hello everyone. Today in this video we have to solve problems on Poisson distribution. Before we are going to solve the problems, first of all we recall some basic concept of Poisson distribution. We know all of you if x follows Poisson parameter lamina. For binomial parameters of n comma p. For Poisson, the lamina is the only parameter, and probability distribution, probability mass function, I can say that x is equal to r is to the power minus lamina power r by r factorial, where r is equal to 0, 1, 2, so on. Okay, so Poisson distribution is a limiting case of binomial distribution, because n terms to infinity indefinitely very large and p to 0, the constant probability of success for each trial is indefinitely small. Because probability of success is small, then np is equal to lamina is finite. So we have to remember this. Poisson distribution is a limiting case of binomial distribution. So, and this is also we have to remember. And next, we know for the mean for the Poisson distribution, expectation of x is equal to lamina, and variance of x for the Poisson distribution is also lamina. So we have to remember this property, because in this Poisson distribution mean is equal to variance. So for binomial distribution, variance is greater than mean. Okay. Not, it is not correct actually. For binomial, mean np is greater than npq. So for binomial distribution, mean is greater than variance. We have to remember this, which is important also. And we have to remember for this Poisson distribution. And MGF for Poisson distribution, that is e to the power minus e to the power lamina into e to the power t minus 1, which is a MGF. Recurrence for Poisson distribution, p of r plus 1. So some books say that in place of r we take some of most of the x, p of x plus 1, but we take p of r plus 1 is equal to lamina by r plus 1 into probability of, and it satisfies additive property, because some, if xi follows Poisson of lamina I independent, then Summation of xi also follows poisson of lambda. So these are the basic concepts we have to remember. And applications, I am not writing applications, but I am telling that applications for Poisson distribution are number of suicides in a city and defective items in a large lot when piecemeal, and printing mistakes per page, calls received per hour at exchange, and death due to heart attack or snake bite, not epidemic. These are the real life applications for the Poisson distribution. Okay, and I am also writing extra for skewness. That is beta 1 is equal to 1 by lambda. So, and also I am reviewing that Poisson distribution is always skewed distribution. We have to remember this because lambda to infinity beta 1 is equal to 0 and beta 2 is equal to 3. The Poisson distribution is always skewed distribution. So these are the basic concepts we have to recall once before going to problems. So now we are moving to problems. If x follows Poisson of 2, find probability of x greater than or equal to 2, and also a given that e power minus 2 is equal to 0.1353. Okay, we have to find the solution. We know that probability of x is greater than 2, then we have to find one minus probability of x is equal to 0 minus probability of x is equal to 1. This is a formula we have to for probability of x is greater than 2, and we are also finding another way, but I am choosing this way for simple calculation. That is 1 minus x is equal to 0, so we get e power lambda only, that's why e to the power of minus 2, and next e to the power of minus 2 for x is equal to 1 into 2, because we have to substitute, because I am not substituting this, we have to substitute this probability of x is equal to 0, then we take e to the power of minus lambda into lambda power x by x factorial. We put x is equal to x plus 0 lambda plus 2, then we get these answers. Okay, that is 1 minus e to the power of minus 2 is 0.1353 minus 0.2702. Then we get probability of x greater than 2 is equal to 0.5941 is our required answer. So next question we have to move. For a Poisson variate, probability of x is equal to 1, probability of x is equal to 1, that is equal to probability of x is equal to 2. Asking find mean So which is very simple if you know the concept, because we know that mean is equal to lamina. So we have to find lamina value only. Mean and variance are the same. So mean and variance also lamina. So we have to find mean. First, probability of x is equal to 1, that is equal to probability of x is equal to 2. We know the probability mass function. So that is e to the power of minus lamina into lamina power x by x factorial, e to the power of minus lamina power x by x factorial. We take x is equal to 1 here, x is equal to 2 here. Probability of lamina into 1 into the power of minus lamina square by 2. These will remain 1 lamina. Then we get lamina is equal to 2, which is the mean. Okay. And next question. Find mode of poisson 4.7, which is given. So we given that lamina is equal to 4.7. We take it as a mean or variance, because for Poisson distribution mean and variance are same. So if lamina is a integer, the modes are, I am writing that lamina is integer, modes are lamina and lamina minus 1. If lamina is not integer, mode is equal to only lamina only. So here integer 4.7 is not a integer, so that's why we take lamina is equal to 4.7, that is taken as mode is equal to 4, which is our required answer. Next question. Using MGF of Poisson, show expectation of x is equal to variance of x is equal to lamina. So it is a concept based question. We know that MGF of Poisson distribution is e power lamina into e to the power of t minus 1, which is the mxt. Then we have to find m dash t, that is lamina e to the power of t, e to the power of lamina to e to the power of t minus 1. We get expectation of x is equal to m dash, take t is equal to 0, then we get lamina, that is mean. M double dash of t, that is lamina e power t, e power lamina e power t minus 1 plus lamina square e power 2t e power lamina e power t minus 1. Then m double dash of 0, t is equal to take 0, lamina plus lamina square. Then variance is equal to m double dash of 0 minus m dash of 0 whole square, that is equal to lamina plus lamina square minus lamina square. It is answer. Then variance is equal to lamina, we get. Next question, if x follows poisson 2 and y follows poisson of 3, then x, y are independent. Find probability of x plus y is equal to 4. So I am already explaining in the concept world. Then x and y are the independent variables. Then we x plus y follows poisson of, so lambda 1 plus lambda 2. So x plus y follows poisson of 2 plus 3. We take lambda is equal to 5 here. Or we have to find probability of x plus y is equal to 4 only. So we simply we write e to the power of lambda to the power of x plus y by x plus y factorial, e to the power of minus 5 lambda power 4 by 4 factorial. So lambda value 5. Then we get e to the power of minus 5. So you values are substitute. You only substitute the values. I am not writing this. I am writing final answer, that is probability of 0.175. Okay. If you find probability of e to the power of minus 5, 5 power 4 and both multiplied, and after that dividing by 4 factorial, then we, that is 4 factorial means 4 3 into 2 into 1, 4 3 is 12 to the 24. The 4 factorial we get 24. Same remaining also you also find the same way. You have to check the answer. So the state conditions, so which is very interesting question. State conditions under which binomial tends to poisson if n is equal to 200, p is equal to 0.02. Find probability of x is equal to 5 using poisson. So simply we have to find the condition for the poisson. We know n is large and p is small. So np is equal to lambda finite. This is our required assumptions. So we know that np is equal to lambda. So for Poisson distribution also mean is equal to same 4. And probability of x is equal to 5. Okay. E to the power of minus lambda power x by x factorial. E to the power of minus 4, 5 power 4 by 5 factorial, because 5 factorial we get 24 into 5, then we get 120. So it is a 5 factorial is the answer 120. Then remaining you find and substitute, and finally we get probability of x is equal to 5 is equal to 0.156. So which is very simple question. Now next move to next question. So number of accidents per day in a city follows Poisson distribution with the mean, that is lambda 2. Find probability that on a given day, first one, no accident. Second one, at least 3 accidents. So from this data we know lambda is equal to given already city given mean is equal to 2, so that is equal to lambda, that is equal to 2, and we know e to the power of 2 also 0.1353, we know this value. Then we have to find a probability of 0 because accident is 0, so x is equal to 0, I take e to the power of minus lambda power x by x factorial, then e to the power of minus 2 power 0 by 0 factorial, and we get e to the power of minus 2 is equal to 0.135, which is the first one is completed. Second one, for at least 3 accidents, so I denoted a probability of at least 3 accidents, so that is equal to 1 minus probability of x is equal to 0, probability of x is equal to 1, probability of x is equal to 2. So 1 minus probability of x is equal to, already we find that probability of x 353. Then we have to find probability of x is equal to 1 and probability of x is equal to 2 in the same way, placing 1 instead of 0 and placing 2 instead of 0. Then we have to get the answers 0.2706 minus 0.2 minutes. I have to finding this. So we have to find this because I am finding this video, it will take extra time. So that's why final answer I am writing probability of at least 3 accidents, that is 0.324 is our required answer. So which is question is only difficulty, but if you observe carefully, then answer is also very simple. So x follows Poisson 3, find probability of x is equal to 2 by x is not equal to 3, and solution, from this data we given that lambda is equal to 3. So we have to find a probability of x less than or equal to 3. So same way we have to find the values, because we already find this type of problem so much, so that's why I'm not calculating these values. Okay, I'm directly writing answer. So I am only writing e to the power of minus 3 is equal to 0.0498, which is only I am writing. I am directly writing answer is 0.647, and probability of x is equal to 2. Then we get direct answer 0.224. then because you have to substitute e to the power minus lambda power x by x factorial. In x place we have to take 2, lambda place we have to take 3. So after that we get this answer 1, and we have to find also this. Then we have to find the probability of x is equal to 2 by x less than or equal to 3. Simply we get 0.224 by 0.647, and we get 0.346 is our required answer. So we're moving to next question. If x follows Poisson of lambda and p of 2 is equal to 3, p of 1, find lamina. So which is also concept based question. So by recurrence, probability of 2 is equal to lambda by 2 into p plus 1. So if you want to lambda r plus 1 by p of r, which is the recurrence. So same way we have to find recurrence for probability of 2 is equal to lambda by 2. We get okay. Then after we getting the p of 2 is equal to lambda 2 by p1, then we have to p of 2 is equal to 3 p1, p2 is equal to lambda by 2 p1 into 3 p1 cancel, then lambda is equal to 6 we get. So I'm checking once again. Okay, you move to next question. I have to giving that all cumulates of Poisson are equal. Okay, we have to remember this. All cumulates of Poisson are equal. You have to remember this. Next question. Calls arrive at helpline at rate 5 per hour. Find probability of exactly 3 calls in 30 minutes and the probability of at least one call in 12 minutes. So they given that rate is equal to 5 per hour. For 30 minutes, lambda 1 is equal to 5 into 0.5. Then lambda 1 is equal to 2.5. And also for 12 minutes, lambda 2 is equal to 5 into 0.2 is equal to 1. Then lambda 2 is equal to 1, lambda 1 is equal to 25. Probability of x exactly 3, that is e to the power of lambda 1 minus 2.5, 2.5 power 3 power 1 by 3. Then we get final answer 0.138. So we have to calculate this. And probability of at least one call, that is 1 minus probability of x is equal to 0. Same way we put x place into 0, then we get final answer 1 by 1 minus 1 because lambda 2 is equal to 1, that's why you take 1. Then 0.632 is our correct answer. Okay, we have to meet in the next video. These are the questions for the probability distribution, which is help to solve questions in related exams that are uses your anything which is worked well.